Bismillahirrahmanirrahim. Hi everyone, I hope you are all doing well. I welcome you all to the class of Real Analysis by Walter Rudin. Our chapter number 3, Numerical Sequences and Series is continue. In the last lecture, we discussed about diameter of a set. In today's lecture, we will discuss an important theorem, Theorem 3.10, which is related to the property of a diameter. In this short video, I will discuss its first part. This says if E clear is the clear of the set E in a metric space X, then we have to show that the diameter of clear of a set E is equal to the diameter of set E. Firstly, we will revise some of the basic definition that I will use in the proof of this theorem. What is the clear of a set E? For any set E, its closure is given by the union of two sets E and E dash, where E dash is the set of all limit point of E. What does mean by the limit point? A point P from a metric space X is called limit point, of set E if every neighborhood of P contain at least one point of E other than P, or equivalently we can define the limit point in the mathematical notation as a point P belong to X is called limit point if for every positive real number epsilon greater than 0 there exists a point P dash belong to E such that P is different from P prime and the distance between these 2 points is less than this positive real number epsilon. So this is the equivalent definition of limit point. Next, the diameter of set E can be defined as it is the supremum of all the distances that can be made for any 2 points X and Y from set E. So diameter of set E is the supremum of these distance. If you have no concept about diameter of set E, how can we find this? You can watch my last video. In that video, I have given the brief concept of diameter of set E. So, to prove the result, we will show these two inequalities because here we have to show this equality. So, the diameter of set E closure is equal to diameter of set E. In a real analysis, when we have to show the two real number X and Y are equal, one of the strategy that we can use to prove, we show that X is less than or equal to Y and Y is less than or equal to X. So here I will use the same strategy. I will show that the diameter of the E closure is less than or equal to diameter of E and diameter of E is less than or equal to diameter of E closure. So firstly, the first part, this second part, this inequality is clear from the definition of E closure, as here E closure is the union of two sets E and E dash. By definition of union, E is like we say, if when we find the union of A and B, this is given by A union B, then clearly you know A is a subset of A union B. Similarly, B is also subset equal of A union B. That is, both of the sets A and B are the subsets of their union. So by using this concept, we can say when E closure is equal to E union E dash, then E is clearly subset of E dash. If E is a subset of E dash, then diameter of this set E is always less than or equal to diameter of E closure. And this fact is clear from this definition. We know if A is subset of B, then the supremum of the smaller set is always less than or equal to the supremum of set B. As diameter of any set E is the supremum, is also this is the supremum. So that's why that as supremum of A is less than or equal to supremum of B, this implies the diameter of A will less than or equal to diameter of set B. So when you say E is a subset of E closure, then diameter of E will be less than or equal to diameter of E closure. Say this is 1. Next we show that the diameter of E closure, that is this part of this proof. For this, let epsilon be any fixed arbitrary real number, and we choose any 2 points P and Q from the left side, that is E closure. Choose P and Q be the 2 points of E closure. Then by definition of E closure, what is the definition of E closure? E closure is the union of the sets E and E dash, where E dash is the set of all limits point of E. It means P and Q, when P and Q belong to the E closure, then P and Q are the limits point of set E. So by definition of limit point that I have discussed in the start, we can find 2 points P dash and Q dash from set E such that the distance of this point P from P prime will be less than epsilon. Similarly, the distance of Q from Q dash will always less than epsilon. Say this is 2 and this is 3. Next, I will use the triangle inequality between 2 points P and Q because I have taken these 2 points P and Q from set E closure, and I have to show the diameter of E closure is less than or equal to diameter of E. So to prove diameter, I will find the distance of these 2 points by using triangle inequality. So by using triangle inequality for the 2 points P and Q, this can be written as distance of P from P dash plus distance of P dash to Q dash plus distance of Q dash to Q. That is, this whole inequality is the triangle inequality that I have made by involving these 2 points P prime and Q prime here. Now by using 2 and 3, from 2 and 3, what is 2 and 3? By 2, this distance is less than epsilon, and this is also less than epsilon. So by replacing this by epsilon, and this is also less than epsilon, so epsilon plus epsilon, this gives 2 epsilon, and this is my third number, distance of P dash and Q dash. Now lastly I have to convert this inequality in form of diameter. Again I will use the definition of diameter. As the diameter of E closure is given by the supremum of the distance of 2 points P and distance of any 2 points of E closure. I am finding the diameter of E closure. The definition says I will choose any 2 arbitrary point from E dash, and I will find the distance between them. Now suppose this set has a 100 distances. Now the maximum distance from this set will give the diameter, that is, diameter is the supremum. For example, suppose I have a closed interval 1 to 3. I have to find the diameter of this 0 to 3. Suppose I have to find the distance of this diameter of this set. As you know, there are infinite point lies between 0 and 3. So from we can choose any two fixed point from this interval, and we can find their distance. Suppose this is 0.1 and this is 1.5. Now what is the distance between these 2 points? The distance is given by usual metric, that is given by x minus y absolute. So this is 1.5 minus 1, this is 0.5. Similarly, I can find, suppose my second point is 2.5 and now I take 1.5. This gives the distance is 1. So I can find infinite many point from this interval, and I can find their differences. What is the largest difference? The largest difference is given by these 2 points, 0 and 3. That is 3 minus 0. So the diameter of this closed interval is given by 3. That is given by finding all the distances by using this metric. So in short words, the diameter is given by the supremum of all distances. So when we take supremum of this number, this gives diameter. It is clear that without supremum, this number will always less than or equal to diameter. Again you can focus that the diameter is a supremum of this set, and supremum is always greater than all of these numbers. So that's why this distance P and Q will always less than or equal to the diameter. The key point is that supremum of any set A is always bigger than or equal to all points, any point x of this set A. So this is the key point that I have used here. So distance of PQ will be less than or equal to diameter of E bar. Similarly, when I will use the definition of diameter of E, now as the points of E are denoted by P prime, Q prime, so the distance of these 2 points will be always less than or equal to the diameter of E. So 4 implies, the last inequality implies this distance is less than or equal to diameter of E, and this distance is less than or equal to diameter of E. So this can be replaced as diameter of E equal here, and this can be replaced as diameter of E. So 4 becomes in this form. Lastly, since epsilon is an arbitrary real number, so when epsilon is very small, because we can make this number as small as we wish. So when epsilon is nearly close to 0, then these 2 numbers, diameter of E equal here and diameter of E, will become equal, but the left side will always less than, because epsilon is approaches to 0, but we cannot take it exactly equal to 0. So that's why this number is less than or equal to diameter of E. By using the fact, we can make epsilon as small as possible. So combining 1 and 5, in the 1, diameter of E was less than diameter of E equal here, and in 5, diameter of E equal here is less than or equal to diameter of E. Hence this gives the equality that both are equal, and it completes our proof. I hope you have a now clear understanding about this lecture. Inshallah, in the next lecture we will discuss its B part. If you find this video helpful, kindly like, share and subscribe. See you in the next lecture. Take care. Allah Hafiz.